Hi there, I'm Hannah and I'm going to tell you a bit about our boats kit. One of the best things about this kit is that it is a completely open source kit and lesson plan, and it is available not only on the MyStemKits website, but also on Instructables and Tinkercad. In Instructables, simply search for MyStemKits, and then in Tinkercad, you're going to want to go into the Learn tab, and from there, under Projects, look for the one with the MyStemKits logo. Once you have access to the models, there's something to note about the difference between the different models available. In the MyStemKits website, by default, under large print sets, you will find these nice smooth models that we have along the back here. And these were the original designs. But with the open source lesson plan that we have and the different design challenges, where the students are actually then being pushed to not only evaluate the 4 designs we provide, but then go on and design and model their own to then test in the same way, we wanted to show the students that you could build complex shapes, such as our boats, even in a simpler software such as Tinkercad. So we then recreated all of our boats using Tinkercad, and you can see that some of the shapes are a bit less smooth curves, but you can still get the same general shape. So those are available as the open source models in Tinkercad and Instructables, and they're also available in the small part sets of the website. Well, let's talk about some of the things these boats have. You'll notice that in addition to having different shapes and sizes, each boat also comes included with a rear peg, which is used for gripping, side pegs, and a front pull loop. These different features, as well as the letter on the side, can help you easily identify them and then test them in a variety of different ways. Moreover, the kit also includes a ramp, which I have taped here to the side of my tub, which I will use for all of the different testing. In elementary school, you can use this kit to simply test which objects float and which ones don't. So you can drop in something metal and it'll sink to the bottom, whereas if you put a boat in here, it'll float. But as you get into middle school and high school, this is a really good chance to get into graphing and analysis of a complex problem, specifically when it comes to a cost-benefit analysis. And then the students can go design their own to try and make one that's even better than the 4 we have. The first thing you need to do is de-support them, so simply use pliers and break the supports off of the models. Next, you can get to testing. The first thing to test is carrying capacity, so choose the boat you want to test with, set it in the water, and then find a relatively equal unit of weight. In this case, I'm going to use nuts, but you can also use washers or pennies or anything small that has a consistent weight to it. So you can drop these one at a time into the boat to see how many it holds. Make sure as you drop the weights in that you are evenly distributing them along the sides and front to back. Students can practice counting in elementary school to see how many it can hold, and then in middle school and high school you can then analyze and graph that data. While you're doing this, it gives your students a really good chance to both hypothesize about the expected outcome and also talk about proper scientific and experimental procedure so that they can make sure that the data they're collecting is valid and sound and that they won't have any skewed data based on how they go about their experimentation. The next type of test you can do is for stability. And you can do this test either with a few weights already in the boats or without the weights at all. And so what you would do with this is to set up your boats, and then you simply use large paper clips and slide them over the side pegs to see how many it takes before it will sink the boat on its side. Another test you can run with them is its steerability. And the way to test that is to see how well it goes in a straight line. And so you can have the students make notes of all of these things and then come up with the best solution for the specific scenario. So whatever activity you're doing with these kits, whether you are simply seeing what objects float versus sink, whether you are testing them to just see how much they can hold and have students try and design a boat that can hold the most weight, or if you're getting into those really complicated real-world scenarios with open-ended answers where the students have to really analyze and engineer solutions to complex problems. We know you are going to enjoy using this kit and all the different ways that you can bring science and math together in an integrated, hands-on experimental activity in your classroom, and we can't wait to see how the students react to this activity. Thank you so much for listening and have a wonderful day.